Hi guys, this is just an example of how to organize your data in a stem and leaf plot. So stem and leaf plots can be a useful way to just kind of quickly be able to glance at your data and see trends in the data. Today in class we estimated 60 seconds, and let's pretend that this is the data that we got, or in a different class we got this data for what time students thought was 60 seconds by closing their eyes and estimating. So if we wanted to kind of organize this data so we could better look at it and see where the most frequent estimations were, we might want to use a stem and leaf plot because it's less writing and it's a little bit easier to glance at and see trends with. So with making a stem and leaf plot, we do want to identify what our largest numbers are and our smallest numbers. So I've found my maximum was 112 seconds and my minimum was 35 seconds. So a stem and leaf plot doesn't have to show all numbers, but it does need to show the full range. And the stem is the left side, and it shows the number of tens. You don't have to write this down, but it might be helpful. We'll do an official math notes on this later. So this is the number of tens. So in 35 seconds, there's 3 tens. And the leaf side shows the number of ones in each set of data. So 35, we would write with the 3 tens on this side and the 5 on this side. So we'd read this as 35 seconds. We're going to just kind of go through, and with the knowing that we're organizing our data, it is helpful to write the leaf side with the least number first, and then have the numbers get bigger and bigger. So we kind of want to scan and see if we can find the least amount of 40s, and it looks like there's only one 40, so 47 goes in that row. And it's good to mark your numbers in some way to know that you've included them on the graph. So an underline or circle or something when you do put that data on your graph. So now I'm looking for my 50s. 52 and 53 should be on my graph, so I'm going to put a 2 here to represent 52. And with the stem and leaf plot, it is helpful to leave space between your data points so that it's clear that this isn't 23, just to remind us how we read this. You could also put a comma, I guess, but typically they don't have commas. So 60s, so I have 61. That's one of the lower numbers. 63 and 65. So I'll put a 3 and a 5. And then, 59. I forgot 59. I'm going to underline that and put that on the 50s row. And then 70s. Oh, there's 2 75s. 75, 75. And 80s, 89. And now it looks like there's no 90s, there's just this 112 left. And a 112 doesn't have just 10 tens, it has 11 tens. So 112 we would write like that. So this is our stem and leaf plot. It's all of our data in an organized way, and I can definitely see from looking at this that most people's estimates fell somewhere in the 50s to 70s range, which kind of makes sense, and that the lowest and the highest were quite far from 60. So stem and leaf plots can be really helpful to kind of see the trends in the data. We'll talk more about this in class tomorrow, but I did want to just give you a more clear example in case you were still feeling a little bit confused. Thank you very much.